In this last example, we want to use the properties of logs to find the approximate value below. We are not to use a calculator. And this is kind of a tricky problem because we're not given these nice logs that we can find the values easily. So that's why we're actually going to have to use these approximations to come up with another approximation without a calculator. And here's what I mean. If I had log base 9 of 3 or log base 9 of 81, I could calculate that pretty quickly in my head. But I'm going to need to use these pieces, these like ingredients, to figure out what the final answer is, or final evaluation of this piece here. Log base 9 of 8/5. No clue off the top of my head. So really the thing to think about is we're given all of these examples or these approximations as tools or as pieces of this log here. And here's what I mean. I want to try and break down using the properties of logs, and I want to expand this logarithm here. And my hope is I want to find, I want to like use possible 12, 5, or 8 since I'm given logs with base 9 of 12, 5, and 8. If I'm seeing factors of these things that I can use a 12 or 5 or an 8, that's what I want to break this thing down into. And I should also add to this, what it's not listed in here is powers of 9. If I had a power of 9, since I'm log base 9, I could figure out what that value is pretty quickly. So here's what I mean, and if this isn't making sense, hopefully you'll understand it once we actually do this example. See, here I have a quotient property at play, so I'm going to actually take this log and I'm going to break it into log base 9 of 8 minus log base 9 of 25. Actually, I know what log base 9 of 8 is. That is this right here, so that's great. That's what I'm after. So now I can actually make that substitution since I have that approximation in terms of something I already know. But I'm not quite finished with this one. I would like to get this to be in terms of either 12 or a 5 or an 8. Well, I know that 25 is equal to 5 squared, and so I can use that to my advantage here. And I can rewrite this one more time as log base 9 of 8 minus log base 9 of 5 squared. And then if you remember that power property, I can bring this out in front here as a coefficient. And so that's going to equal log base 9 of 8 minus 2 log base 9 of 5. So here's where I make the substitutions. So I know that log base 9 of 5 is 0.7, and I know that log base 9 of 8 is 0.9. So I'm going to substitute this in as 0.9 minus 2 times 0.7. And again, this is a non-calculator problem, so I do need to kind of calculate this on my head, or I can write it out if I need to, but this is 0.9 minus 1.4. It's kind of like 9 minus 14, so this is going to equal a negative 0.5. So again, I use the properties of logs to break down and expand this logarithm, and then use the pieces that I did know to come up with a final answer. Let's see one more example before I have you try one here. So we've got another similar problem, but now a little bit larger of a number. So something that helps me is I might actually break down, if you don't see apparently right away where I can pull a 5 or 9 or 6 out, let's actually break down 96 into its factors. So I know that 96 is, let's see, that's 12 times 8. Okay, none are there. Oh, but 12, that's 6 times 2 times 8. And this is where now actually we have to get a little bit clever, because I can't break down 2, obviously, or 8 into a 5 or a 9 or a 6. So, but what I can do is if I write this as 6 times 16, 16 is a power of 4. So this will be used to my advantage. 96 is the same thing as 6 times 4 squared. And so because I have this now as a power of 4, I can use this when I break down my logarithm. So let's see what this looks like. Let me switch up the colors here. So log base 4 of 96 is the same thing as log base 4 of 6 times 4 squared. And that's going to be equal to log base 4 of 6 plus log base 4 of 4 squared. Now I can use this log base 4 of 6, my approximation, to say that that's the same thing as 1.3 plus log base 4 of 4 squared, that's equal to just 2. So 1.3 plus 2 is equal to 3.3, and there is my approximation. So I had to be a little bit clever here, but just don't discount that as long as you have any power of this base, you can use that in your expansion as well. So why don't you try the next example here, pause the video, give this one a shot, and see if you can't make some sense of it. Here are my final solutions for A and B with my work provided. Hopefully it made some sense. And I think I'm going to turn it over to Eliana for another message. Do you have anything that you'd like to say to the viewers?
Yeah.
What would you like to say to them?
I tried that.
Hey Ellie.
But,
Eliana.
but,
Do you want to learn about writing equations?
no.
You say, in this video we're going to learn about logs.
You don't even let it up.
Say we're going to learn
You don't love
about,
dogs.
not dogs, logs.
Dogs.
Logarithm? You say logarithm?
Logarithm. Logarithm.
Do you want to turn it off?
No, I didn't take a movie.
Can you say inverse?
You're reverse.
Exponentials.
Exponentials.